Kia ora koutou. This is a really nice hard question for Aaryan from the June 2022 paper for Pure 3, and it's one that's just all about differentiation. The examiner's report noted that the second part was really badly done, and I'm going to do that in two slightly different ways. So if you're in my class this year, I want you to pause the video now and have a good go at the question and try and think of what two approaches we could use to do part B. Okay, so let's just read through it. The first bit is a pretty easy 4 marks, which is just some implicit differentiation. We're given this equation for a curve, and we have to get dy by dx in terms of x and y, right, the usual thing. Then we're told that we've got the tangent to the curve at the point where x is equal to 0, which obviously is going to link back to part A, and the tangent where y is equal to 0, that they intersect at the acute angle alpha. Now, straight away, you should be thinking about something we learnt in level 2 coordinate geometry, which was that when we've got an ordinary old straight line, and I'm going to try and draw one with an old-fashioned ruler and see how this goes. Here we go, good enough. Oh, it's gone away. Why is it gone away? There, okay. So suppose that that line is y equals 3x. Then if we look at the gradient of that line, which is 3, we can see that if we've got angle alpha in here, that we've got dy by or delta y over delta x is equal to 3 over 1, right? So tan of alpha is equal to 3. And we can use that in a slightly more complicated way for the second part of this question, right? Just also note, let's get rid of that graph, that we're going to have two tangent lines, and they are going to be sitting somewhere in my xy plane, right? So I'll just draw those in. So we don't really know much about them yet, but we know that they are going to intersect, maybe like that, maybe not like that. And so we're looking for this angle in here. Now what we could do is we can shift them so that they are sitting on the origin. Let's just try and make a different color. So here are my xy axes, right? And if they are my two tangent lines, which I figured out somehow, then the angle in between, the acute one that we're looking for, is this one here. But we're going to know the gradient for those two straight lines, so we could use a compound angle identity pretty easily to figure out what alpha is. Okay, and that's the approach I'm going to take later. I'll call that angle beta, and this one will be alpha plus beta, but you can label that in different ways. Okay, so there's your big hint. Now I want you to go and try that question again with that hint. Okay, and finally I'm going to work through the whole thing. I'll just get rid of this picture here and get into it. Right, so x cubed plus y cubed plus 2xy plus 8 is equal to 0. I'm going to differentiate everything with respect to x. I get 3x squared plus 3y squared dy by dx. I've got a product rule thing going on here, so I'm going to have plus 2x dy by dx plus 2 here times y plus 0 equals 0. So that's the first part done. We should check that before we go on, but we get, gathering things up, 3x squared plus 2y plus dy by dx times 3y squared plus 2x is equal to 0. And we just do our usual thing, so dy by dx will be negative 3y squared plus 2x, subtracting that from both sides, over 3x squared plus 2y. Right, now you can make that a bit prettier, you can expand it out, do whatever you want. I think in my work solutions I've done this, so I did expand. I got negative 3x squared minus 2y over 2x plus 3y squared. Right, well worth quickly checking back and making sure you haven't mucked that up. Now, the next thing is we want to know, so that's the first 4 marks, the tangent to the point to the curve at the point where x is equal to 0, and then the tangent where y is equal to 0. So my tangent depends obviously on x and y. So the first thing I need to do is to say, well, when x is equal to 0, what's y? And when y is equal to 0, what's x? And that's quite fast to do. So when x is equal to 0, we've got x cubed plus y cubed plus 2xy plus 8 is equal to 0. So 0 plus y cubed plus 0 plus 8 is equal to 0. y cubed is -8, giving us y is equal to -2. So the first tangent gradient that we're going to work out has got this point. We'll call that P1. The next one is where y is equal to 0. So we have x cubed plus 0 plus 0 plus 8 is equal to 0. And x cubed is -8, giving us this time x is -2. So P2, the second point, is going to be -2, 0. Now we can work out the gradients of the tangents at those two places. So M1, remember that my gradient is -3x squared minus 2y over 2x plus 3y squared. So substituting into this gives me 0 plus 4 over 0 plus 12, 3 times 4, which is 1/3. And in my second point, I get -3 times 4 minus 0 over -4 plus 0, which gives me -12 over -4, which is +3. Now, I think there are probably quite a few different ways you can go from here, but because this felt like a hard question and I've got the 2 points, it was quite easy for me to draw a graph of the 2 tangent lines where they actually are sitting before I shifted them to make it a bit easier. Okay, so I'll just pause the video to get the axes back up. All right, so at the point 0, -2, we had m is equal to 1/3. So we can go back to here. So x is 0, y is -2, and my gradient here is a +1/3. So something like that. And the other point was at -2, 0. So it's here, and the gradient here was a much steeper 3. So if we draw it roughly like this, and we can see now what's going on. We're looking for this angle in here. This is alpha. Now, I don't like working with it like that, so I'm just going to pick them up and plonk them into the middle of my XY plane. So this is now turning into maths with very bad drawings, but there you go. So here we have alpha. This is what we're after. This is beta, and this is alpha plus beta for the whole thing. Using a compound angle, which if you've done level 3 trig, especially if you're doing scholarship calculus this year, this compound angle should feel really easy, right? So we've got tan alpha plus tan beta over 1 minus tan alpha tan beta, and we're just going to substitute in what we know. So we know that this curve here, oops, sorry, OneNote's changed everything, right, there we go, that's got a gradient of 3, this one here's got a gradient of 1/3. So we've got 3 on this side, we've got tan alpha, which is what we're trying to solve for, plus 1/3 over 1 minus tan alpha times 1/3. So cleaning this up gives me 3 minus tan alpha is equal to tan alpha plus 1/3. What next? Right, so 9/3 minus 1/3, so 8/3 is equal to 2 tan alpha, giving me a very nice exact value. Tan alpha is equal to 8 over 6, which is 4 over 3. Okay, so that's one method to do it, and that's probably the one that I would have used because I often notice the tan alpha thing. I also notice students not using it anywhere near often enough. But the other way that we could have done it is to use vectors and to use the dot product idea. And that's probably a little bit faster, and that's what the examiner's report said most students did. So I guess maybe that means that that's a better way to go. If we think about it here, this is the angle that we want, and we know the direction vectors for the two things. So if this is theta, we're not going to get tan theta directly, but we are going to get cos of theta. So the direction vectors for the two things are out 1, up 3, and out 3, up 1. And we can apply our definition, which is that cos of theta is equal to this. So the dot product divided by the magnitudes of the two vectors. So cos of theta is going to be equal to 3 plus 3, which is 6, divided by the square root of 10 times the square root of 10. That gives me 6 over 10, which is 3/5. So you can spot that we've got a 3, 4, 5 triangle happening. Here's theta, we've got 3 here, we've got 5 here, and we've got 4 here. And that means that tan of theta is equal to the opposite over the adjacent, which gives me 4/3. So there you go. I think it's a really lovely question. It ties in so many cool ideas that we've seen in the last couple of years. So thank you for sending it in. I'm hoping that everyone in 13 MCA is out there watching. Keep on sending in your questions, and I will see some of you at school tomorrow.